so here's the ambiguous cases. And when we talked about this concept, we determined that it was when we were dealing with a side-side angle. So when there was a side, and an angle in an order like that, this is when we saw this problem happening. Okay, so here's what happened. If the opposite side was longer than this one, there was only one possible triangle. Okay, so it makes sense, like as I was swinging this around, if this was longer, it would only hit once. If the opposite side was shorter than the adjacent, and also shorter than this exact height, okay, so if you're shorter than this height, you are not going to touch at all. So no triangles happened. If this opposite side was shorter than the adjacent, but longer than this height, so if it was in between here and here, then it could hit twice. And then if the opposite side happened to be exactly the height, then there's one triangle and it's exactly a right triangle. Okay, so that's a summary for you to look at if you need. Okay, so side angle. This time, what if the angle was obtuse? What if the angle was obtuse? Let's think about it. Is there a possible way to have two triangles? If this is obtuse, there's no possible two triangle concept here. The two triangle concept was when the other angle could be an acute or an obtuse. If this is already obtuse, is it possible for this opposite angle over here to be obtuse or acute? No. Can you have two obtuse angles in a triangle? Would that work? If you added 100 and 100 in a triangle, is that ever going to work? No. Okay, so here there's only going to be one triangle ever possible. As long as this side is long enough to reach. Okay? Now, if this side is just not long enough, it's not going to work. Okay? So if this is an obtuse angle, there's no situation where it's going to ever be two triangles. Okay? It just doesn't make sense because it's not going to work that you're going to have two obtuse angles inside a triangle. Okay? Because then it's way bigger than 180 degrees. So that's just not possible. Okay. All right. We did this exact problem on Friday, which was a lot of time ago. So let's do it again. So we started in Altona. So here's what places look like on a map. Altona was there. Dauphin, if you're familiar with Manitoba, Dauphin is north and it's to the west. And Melita is over here. That's how things are laid out in Manitoba. Okay, at each corner, I'm going to draw a compass. Okay, so we are starting in Altona. We're going to head to Dauphin. The path is north 44 degrees west. So that's how I draw that kind of angle. North 44 degrees to the west. Okay, now, before I go any further, do we understand this concept? These lines are parallel. They're north-south. Does that make sense? They're parallel. So where could I flip-flop the 44 using the properties from last unit? 44 could also go there. And do you remember the name of that by any chance? Those are what with each other? Alternating interiors. Do you see the alternating interiors? Okay, so that was 305 kilometers. Okay, now we're at Dauphin. Now we're going to head to Melita. So we have to fly. We're going to go south 21 degrees west. So Dauphin, I'm going to go south 21 degrees west. So that's what that angle looks like. South 21 west. Okay, if I'm thinking parallel lines again, is there any other place I could flip-flop the 21 over to? So if it's on this side, I could flip-flop it onto that side. Okay, now I can put those two together because that's a full angle up there. So 65 degrees. So here's my question. How is the pilot going to get from Melita to Altona, distance and compass? Okay, so this is what we're going to do. I'm going to think about just this triangle right now. We're just going to think about this right now, okay? Simplifying just the diagram. So let's talk about how do we get that? Do we have pairs? Do we have SAS? Do we have triple S? Those are all the things you're going to think about. I have a side, an angle, and a side. So that's cosine law. Okay, so here we go. X squared equals 215 squared plus 305 squared minus 2 times 215, 305 cos 65. Okay, is that remember that formula? Okay, I'm going to work that through and we're going to square root it. Okay, we like that number? Somebody's agreeing with it? Okay, now I'm also going to have to tell the pilot about directions. So we better think about what's the angle over here. So now I have that pair. I could also use the 305 to get that angle. So that's going to make sense? Is that okay? So now that I've done that cosine law to get that side, I'm going to go pairs to get that angle. Okay, so 289.52 over sine 65. And we got a 305 over sine of some angle. Times, divide, and then you're still going to have to inverse on this one, right? See if you can work it out. Okay, so I got a 72.7. Okay, but that's not our answer. That's not the compass bearing. So we're going to have to go to our diagram with a 72.7 degree angle. Okay, so we already had this as a 21 on the outside, and then 72.7 degrees. Okay, when you start compass bearings, you have to start either with a north or a south. Which one of those am I closer to? Am I closer to this north line or this south line with those numbers? What do you think? We're closer to the south now, because in my head I can see that this is more than 90 degrees, right? Once I'm past 90 degrees, I'm definitely past that line. Does that make sense? 90 degrees? Okay, so can we do 180 minus those numbers? So I did those 180 rule because they're all on a straight line. Okay. So here's the compass bearing. So I'm closer, this line is closer to the south. So south 86.3 degrees to the, which one is that, east or west? That would be to the east. So this is the pilot's last leg. Okay, so we did that one on Friday, but I know that was a tricky one, so is that okay? Okay, and then this is a new one we haven't done before. Okay. A surveyor is measuring a lake. Okay, so here's my lake. And the surveyor takes angle measures from 2 points A and B on opposite sides of the lake. On opposite sides of the lake, and these points are 1320 apart from each other. Okay, there's the two ends of the lake. Okay, here we go. There's the directions. From B, so put your pen on point B. From B, the measure between the sight line to the ends of the lake is 129. So that whole angle is 129 degrees. Okay, we're still at B. From B, the measure between the ends is 129. And the measure of the angle between the sight line to A and the one end of the lake is 96. So from A to one of the ends of the lake is 96. So from B, if you look at A and one end of the lake, you got a 96-degree angle. So obviously my diagram is not going to be correct, but so what does it make the other end of the lake? From A to the other end, what do we got left there? So that would be, when you look to the other end, a 33-degree angle. Okay, now let's take our directions if we are looking from A. So get yourself, your body at A. Now when you're at A, the measure between the ends of the lake is 43. So from end to end of the lake, your total is 43. And the last direction, the measure of the angle between the sight line to B and the same end of the lake is 15 degrees. So from A, if you go to B and the same end, you have a 15-degree angle. Okay, because before when we talked about the one end, we picked that end. Okay, so if that's 15, that is 28. Okay, what we're going to try to end up doing is figuring out this distance with the lake. Okay, but we cannot do that at all right now. So what I'm going to do is I'm going to try to break down this information into two separate triangles. Okay, so we have, on this one, we have a 28, a 33, and we know that. So do you see which triangle I'm looking at? There was a 28 there, a 33 there, and I know that that distance is 1320. Okay, now I'm going to look at just this half. I have a 15, a 96, and a 1320. Again, obviously my diagram's just not to scale. I'm sorry about that. Okay, in both triangles, let's get the third angle in them. Okay, now let's talk about our goal. Where are we going to get to our lake with this? So I think this is going to be a goal. I would like to end up with a top triangle or a bottom triangle. And how I could do that is if I got the numbers for these two sides. Okay? Okay, so let's get the number for this side. How am I going to do that? So I'm going to go with a pair and a pair. So 1320 over sine 119 equals x over sine 33. Somebody will tell me if they're not matching. 821.98. Okay, same idea on the right triangle. So I'm going to go pair, pair. I'm going to call this one Y if you're okay with that. Okay, times and divide. Oh, be careful with those numbers with your not mixing them up. Is anybody getting 1406? Okay, now we're at a spot where we can get the lake. So if I just simplify this for you, now I have a triangle that looks like this. You see it? Now I can get the lake measure. So how can I get the lake measure? What kind of strategy will I use? So this is the SAS. So I can use cosine law now. Okay, so lake squared equals that side squared plus that side squared minus 2 of those times the cos of 43.